Hello, and welcome back. I'm saving some of the administrative stuff for announcements, so I want to jump right into the technical part of today's lecture, where I want to talk about this GUI stuff and graphical user interfaces. But as always, if you have any questions, please post them in the general questions forum, and please keep an eye out for my administrative announcements. But I want to get right to this idea of graphical user interfaces. We know, for example, in physics, there are these three fundamental particles in the standard model of particle physics. Things like they basically fall into three categories of quarks, leptons, or intermediate gauge bosons. This is in the standard model of particle physics. In the same way, there are three fundamental objects, or more precisely, classes, that are fundamental to building up any graphical user interface in the context of Java, and especially using the Swing framework. And those three components are, those three fundamental objects or classes are components, events, and listeners. Those are the things that all Java GUI stuff is built off of. And as you learn about inheritance, you learn how classes can inherit from other classes, right? It's sort of very much like biological inheritance, where a child or an offspring inherits both characteristics and attributes from a parent. And in the same way, classes can inherit, and then when they inherit, they're called subclasses from their, or child classes, can inherit from characteristics and attributes from other classes. Those other classes are then called parent classes or superclasses. So, in the same way, this component class is subclassed into a bunch of other classes, things like buttons, labels, checkboxes, and another set of classes called containers. And containers, as we'll see, are simply components. Remember, this is the component class, and we'll talk about what it does. This component class basically represents anything that you might see on a screen. So graphical user interface is when you can have a graphical representation of some program or some computational solution that you might have. Just think of like a program that you use now, any program in Windows or Macintosh, like Microsoft Word or the Chrome browser or any of these things. What you do when you launch them, what you see is different things come up, like a window comes up, and the window can have buttons and labels and text on it. So all of these screen elements are represented by a class called components. And so the kinds of screen elements that they represent are things like buttons and labels and checkboxes. These are the visible screen elements, but they also represent invisible screen elements called containers. And these are simply components that hold and organize other components. This would be a thing like a panel. Like imagine when you look at a window, like an old-fashioned window that you might see, you might notice that it has an outer pane and then an inner glass panel. That's what that panel is. The panel that we refer to here is that invisible glass panel. And on that invisible glass panel, you can organize all of the visible and also some other invisible elements. So you can sort of think of like buttons and labels and checkboxes like stickers. Like my son puts up these stickers on our windows during Easter and Thanksgiving and all these other holidays. So in the same way, a button or a label or a checkbox can be a sticker that you stick on to this invisible panel, this invisible glass panel, and that's what a container is. Contained one of those container types is this panel where you can add in other components. Another container type is a window, and we'll delve into all of this in detail. And the way the a GUI program, a graphical user interface program works, is that all of these components can send out events, little event objects that are then picked up by listeners or listener objects. And when the listener object hears some event, it responds to it and does something. And that's how a graphical user interface program works. One of these GUI programs works. So that was sort of like the 1 minute introduction to all of the GUI stuff. Let's delve into it in more detail now. The thing to remember at this high level is that all of our GUI stuff is going to be made up of three fundamental classes. So there'll be objects from these three fundamental classes: components, events, and listeners. So let's see how these all come together. So before we go back into that, let's step back just a little bit, right? So a GUI component is going to be any object that represents some screen element. Remember, this is the stuff that you actually see when you click some application and it pops up and it's got things like buttons and text boxes and whatnot. And as I mentioned, the other two fundamental particles in this GUI framework that we have are event classes, or objects of the event class, and objects of the listener class. So event and listener objects. These three objects come together and interact with each other to create our GUI application, which we then utilize. Most of these in Java, most of these GUI related classes are defined in the Java AWT library. That's the abstract windowing toolkit. And they're also defined in the JavaX extensions .swing package as well. These harken back to the history of Java. Originally, the AWT was the only way to do any of this graphical stuff. So this was the original Java GUI package, and this was a heavyweight package, as we'll see in a bit. The Swing package was added later on to be a little more versatile and flexible, and it's called a lightweight, or the components in it are called lightweight components, as we'll see in a bit. We're not explicitly going to cover JavaFX or Java Server Faces, but of course, there are resources posted where you should look into that. That's a great way to do it as well, where we build up a scene and use that. But this framework of using components, events, and listeners underlies that as well and is used in other languages too. And it's probably the most popular one at this point, and the JavaFX approach is giving it a run for its money, though, decidedly. But both of these packages, the java.awt and javax.swing, are needed to create a full Java GUI-based program, because we need to do both the JButtons and event listeners and all of that stuff. So a GUI container is the other kind of sort of fundamental particle that it's one of those components that we talked about, which is also a fundamental building block for a lot of the programs that we'll be building. And a GUI container is a component. Remember, they're just those three fundamental classes that everything in Java GUI is built from, and the Java Swing GUI is built upon: components, events, and listeners. So a GUI container is a special kind of component that's used to hold and organize other components. So you can have things like a frame. Do you remember? Think of, in your mind, just picture like an actual window with a window frame, the pane that's on the outside, and the little panel that's the glass pane or the glass panel that's on the inside. But the frame is the container, and it's displayed normally as a separate window with a title bar. It can be repositioned and resized on the screen as you want. And a panel is sort of like that invisible glass panel that we talked about, that little invisible glass pane. It's a container that itself cannot be displayed, but it can be used to organize other components. So it's sort of like that invisible glass pane or panel. So you can put these stickers on it, and the stickers consist of visible components like buttons and text boxes. And then you can add that panel, or that invisible glass pane, to another container like the frame, or to some other already visible panel that you have, and then it'll display those elements that are stuck onto it. That's the general way that it's organized. So here's this imagery that I was sort of talking about. If you think of a normal window, a real window, it's got a frame and then an invisible glass pane, and you can put little stickers on there, and it organizes it. And if the glass pane is nice and clear, you can't tell that there's anything there. The stickers look like they're just floating over there. In the same way, the J frame is the window itself. Then there's a content pane, which is this yellow component over here. That's the invisible component. And you stick onto that invisible component. You put in certain places the components that you want to be visible. things like the button, the text box, text area, etc. Those would be the components that are stuck on there that are then eventually displayed. So one of the things I do want to distinguish between is the idea of a lightweight versus a heavyweight container. A GUI container can be either heavyweight or lightweight. As we said, the heavyweight ones are the AWT ones. And this is both generated and managed by the underlying operating system. So in the early days of Java, remember we had the model that Java is the write once, run anywhere, the WARA model, the so-called WARA model that it had. So since you wanted to have these GUI applications run anywhere, on any kind of operating system, the designers thought about, well, how do you actually create the window components that you have and these graphical elements? And so the solution they came up with is let's just send the instruction to the underlying operating system and let the operating system determine how it should be drawn and what should be done with it. So this is the heavyweight model. It relies on the operating system to do all of the heavy lifting. But then it turned out that the way that a Macintosh rendered a window was very different from the way that a Windows machine or a Linux box represented a window. So to sort of have a little more uniformity and homogeneity between these different Java applications running on these vastly different operating systems, another approach was taken where you create what are called these lightweight components or containers. And these are generated or managed by the Java program itself. And this is usually the model that we use in Swing, where Java actually draws it directly and gives more hints to the operating system on how to render the graphical components that are there. So that way you have a little more uniformity of presentation. The exception to that is going to be the J-frame, because that has to be a heavyweight object because the underlying operating system determines what that looks like. And so sometimes this distinction is important, usually not. But the J-frame is a heavyweight container, but the J-panel is a lightweight container. So the main advantage of these J panels, and remember, a panel is just a kind of container, which is a component that can hold or contain other components or containers. And so you can make this very complex containment hierarchy to make sure that the presentation, that the layout of the different objects and components that we have is exactly the way that you might have wanted to see it. And so this hierarchy can be quite intricate at times. And the panels are sort of very important, and you're going to see as we start to create some of these programs in the lab that they're going to be very important for what we're going to be doing. And so, just to sort of recapitulate and make sure we're on the same page with this stuff, and start to delineate exactly how the program itself works. Remember that a GUI is created with three kinds of fundamental objects. And these objects are created from these classes, right? And those three kinds of classes, the three classes are component classes, event classes, and listener classes. So we use those classes to create component objects, event objects, and listener objects. And so we've started to discuss this idea of components, which represent screen elements, things that are actually visible on the screen in a GUI application that you might have. And so these objects would represent screen elements like buttons, text fields, labels, menus, and things like that. We also talked about another kind of component called a container, and that was just a component that organized and held other components. Things like, so the kinds of container objects or classes that we see are frames and panels and dialog boxes and applets. And the kinds of components they hold are things like buttons and labels and text fields, as well as other panels as well. They can hold other panels as well. So this is what we've discussed so far. We've seen components. Let's now delve into what these events and listeners are and how we can use them. So the model that we utilize in this Java GUI approach is that you'll always have one sort of this is the same model that we use in all of object-oriented programming now, right? You always have two classes that you're going to have. Sometimes you can sort of smudge that a little bit, so I'm saying it as if it's an authoritative fact, but you can fudge that here and there and sometimes squeeze things in. But in general, every object-oriented application that you create should have two classes, a worker or a helper class. This is the helper class that we're talking about, and also a driver application class. Remember, the driver application class is the one that contains the main method, which is the point of entry of execution in an application. So that's whatever instructions are in that main method are executed one at a time. And so within that main method, you'll eventually build objects of another type, and that type is the helper class data type that you have. So we saw that, for example, when we were trying to keep track of student grades, we had a helper class called student, and then we used the student class in the driver application, in that main method in that driver application, to create student objects. And then we could use those student objects with the dot operator to do things like tell it to calculate your own final grade. Now, that'd be a great thing for you to have as students as well, if I just let you do that. So you can see that we don't actually do that. Students don't actually calculate their own grade, but student objects are an abstraction of real-world students. So what they do is they have sometimes abilities far beyond normal students as well. But the main idea being that you have a driver application class where you create objects of the type that will help you, and those objects are defined by the helper class. So, for example, if you had a student helper class which defined what student objects can do, you would create student objects in the main method of your driver application, and then have that student object do something useful in order to solve the computational problem that you have. And so in the Java event delegation model, instead of using a worker class and having a separate class like that, what ends up happening is that events are sent from sources to listeners. There's a delegation of responsibility that occurs. So you can think of the model being something like playing catch. And when you play catch, you have one person throw the ball to their friend. In this case, the person that throws the ball is the source of the event. And so the source of the event is usually a component, some kind of object that's of the component class, the type that we saw. So it could be a button, it could be a text box, it could be something along those lines. It will generate an event. And that event itself is the ball that's thrown between these two people playing catch. By the way, this catch is a one-way catch. It goes that way and rarely ever comes back to the event source. So it's really just throw. And I guess it is catch. It's literally catch. So without any of the iteration or repetitive element. So the event source is the object like the J button, some component. It throws an event, it generates an event, and that event is sent to another object, and this object is of type listener. And so when the listener receives the event, it's registered with the object, with the event source. So the listener object registers with the event object, and so as soon as with the component object, so like the J button, and as soon as it generates an event object that it receives, it immediately responds and does something, and it carries out the actual action that you have. So the GUI model is very much like this idea of playing catch. Some components can play multiple games. Remember I said it's one way? So it's kind of one way because some components can play multiple games. They can both throw the ball and catch a frisbee. So this would be something like, or throw a frisbee, I should say. They can both throw a ball and throw a frisbee. And so this would be like a radio button, a J radio button component, which is an object of type component, a certain kind of component object. And it contains the ability to have both an action listener and an item listener, or interact let me say, with both an action listener and an item listener. The action listener is the person with whom it'll throw the ball to, and the item listener will be the person to whom it'll throw the frisbee. You can think of it that way. So the component is the player, and then the player has a buddy. That buddy is the listener. And so the listener is just going to sit there and do one thing. All the listener does is does one thing. It'll either catch the ball or catch the frisbee, but that's all it knows how to do. But it's a very friendly listener, so it can catch a ball or frisbee from many other players. It won't ever throw it back to them. All it does is catch. So the components, all the components do is either throw a ball or throw a frisbee, and all that the listeners do is catch. And they can either catch a ball or they can catch a frisbee. Now the components can throw to multiple catchers, and the catchers can catch from multiple throwers. So the component is the player and the listener is the buddy. And the ball or either the ball or the frisbee, whatever you want to imagine that's thrown between them, that's the event itself. And so the way that it works is that a component object like a button generates an action event. And before it generates that, what it does is a listener object registers with that component object. So it tells the JVM, the Java Virtual Machine, that, hey, this buddy wants to play with this player. So they're put into a game together. They're registered together. Once they're registered together, the player can throw the ball to the catcher. So whenever an event occurs, like someone clicks the button, the component object generates an action event. It tells the underlying virtual machine, hey, I've been clicked, make an event object and throw it to my corresponding catcher, the listener object that's registered to listen for events from me. And so the JVM has registered that, and so it passes the event object to the corresponding listener object. And when the listener object, that's your listener buddy, all they're doing is just listening, and they're waiting. And as soon as someone tells them, okay, here comes a ball or here comes a frisbee, they catch it. And as soon as they catch it, they perform some action, right? This is the helpful action that they might do. They might do something helpful like print out something or write something out or do some calculation. But that's the general model that we're doing with these fundamental particles. And here are our three fundamental particles: the components, the events, and the listeners. And the components generate the events, which go to the listeners, and the listeners respond to the events that they're registered to receive by performing some action. And all of this is mediated by the Java Virtual Machine. So when an event occurs, the JVM calls the appropriate method of the listener object that's already registered to the component object and passes it an event object that describes the event. And so on the back end, there's a lot of stuff going on, and you can see how these actions and events are added into a queue, and they're kept in that queue, and they're dequeued, and you'll learn about queues as well, and decks as well in your algorithms and data structures class next term. But for us, this is the fundamental idea that we're utilizing. So the final thing that I want to talk about is sort of go through it and follow through that example a little bit. So an event would be some object that represents the activity that you might want to respond to, or that a listener or in your program you might have some response to. So for example, you may want your program to do some action when some event occurs, like the mouse is dragged, or the mouse is moved, or the mouse button is clicked, or when a button is pressed, or when a keyboard key is pressed, or when a timer expires. You can check for all kinds of funky events, all of these and many more, and it gives you a very fine-grained control of what happens in your GUI program as it progresses. The Java API has many classes that represent all these kinds of events that typically occur in most of these GUI applications. And the components, like that graphical J button that we saw, generates, or sometimes in the terminologies, fires an event when that event occurs, whenever that event, one of these typical events like the button is pressed or a keyboard key is pressed. And so the listener object is set up to respond to the event when it occurs. And the listener objects can be designed to take whatever actions we think are appropriate under those circumstances. And that's the important part of it. So the one of the final things that I want to do is reiterate this, and I'll show a little example of it as well. And then I'm going to post a video that might be helpful to you also. Let me see. Why is this? Let me just reduce the size of this a little bit. There we go. So, by the way, if you like some of these snaggy pictures and this metaphor that's used, I'd highly recommend checking out a book. I think I've recommended it before for you guys as well. It's one of the best written books on learning Java. And let me just bring that up, and it's called Head First Java. And so that's where I snagged a couple of these graphics from. And that's what this graphic is as a listener, where it says, my job is to implement the interface. The interface that's talking about here is an interface class rather than the graphical user interface. And then also to register with the button and provide the event handling. And the event, the event that is generated by the source, is its only job is to accept the registrations from the listeners, get the events from the user, and call the listener's event handling method. That's whenever the user clicks the source that's relevant. And the source, of course, is the one that sends all of this. And so the event object itself is the basically the argument, and it carries the data from the event to the about the event from the source to the listener. So the basic idea is that the component object is the source that generates the event. So this is like the button or the text box or the keyboard key that you might have. And the event object holds the information about what happened and is sent as an argument to the listener's method. And the listener object performs the action. And when it performs it, it gets the event object as an argument. So it has all the data and the information encapsulated within that event object and can utilize that. So for example, if it's a mouse click, the event object contains things like what were the X and the Y coordinates, where the click occurred, what time did the click occur, and it even keeps track of when the mouse was pressed to be down, and when the mouse was released to be sent back up. So you have a granularity of data that's in there. You can choose to just ignore it. You can say, I don't care when it was pressed down. I don't care when it went up. I just want to respond. The mouse was clicked and I want to do something. Or you can go into that granularity and say, hey, what happened and what exactly needs to be done about that? So to create a Java program that uses the GUI, we got to use all three of these fundamental classes, the components, the events, and the listeners. And you start off by instantiating and setting up the necessary components that you might have. And then you go on and you implement the listener classes for any specific events that you're interested in keeping track of in your application. And then you establish the relationship between the listeners and the components that will generate the corresponding events. And that process is called registering the listener with the component. And then whenever that component fires or is activated, it'll fire or generate an event, which will then go to the listener object and it'll respond and do stuff. And your program will actually solve whatever computational problem that you might be interested in solving. So I think with that, I want to sort of show you how to actually start to create some of these things. And we'll start to look at some code so we get a good idea of it. And I won't go too far into it, but I want to give you an example so you see it. And you'll, of course, have time in the lab to work with this quite a bit. So what you do is you start off by importing the Java Swing library. You need that. And you have the main method in this class. That means this is an application. And because it has a main method, that means you can actually immediately click it and have it do something. In this case, it's good because it's going to generate a window. And you start off by creating a container. Remember, a container is a kind of component. So in this case, you create the J-frame. The J-frame is, remember, like the window itself, the outer part of the window itself. It's the frame of the window. And you make a particular window frame called my frame, and you give it a title. This will be at the top of the frame. And then you have to do something on that frame object that you just created, the JFrame object. Use the dot operator to call or invoke the set default close operation. If you don't do this, when you click the little X to close the window, nothing much will happen. But when you implement this method, what will happen is it'll call the exit on close. It sets the exit on close parameter, so it'll actually take care of all of the stuff that's needed to close the window, whatever the underlying operating system needs to do that. Remember, the reason this isn't necessary is because we said this was a heavyweight component, one of the few heavyweight components that's in the Swing library, which is mainly a lightweight component library. This is needed because the operating system controls the generation and lifespans of windows. So you need to tell it, hey, you know what? Do whatever you need to get rid of this window when it's done. And pack, and then you call the myFrame.pack and set visible with the true, with the argument with the true Boolean, with the value of Boolean true. Pack, what it does is it basically sets the size. When you start to add components to a Java GUI, there are a couple of schools of thought on how you might want to do that. One is you might say, I want the button to be at exactly this location, and I want the label to be at exactly this location. Right? Maybe you want the button to be at x equals 5, the top left of the button to be at x equals 5 and y equals 3, and the text field to be at x equals 50 and y equals 30. You want it to be at those exact positions. Well, it depends what kind of resolution on different operating systems, on different machines with different resolutions and different pixel width definitions. You might not have something look exactly the way that you thought it would look on one operating system. It might not look exactly the same, and it might look actually widely different, starkly different, and maybe kind of messed up. So in order to avoid the dangers and pitfalls of absolute positioning, you can do that, and it turns out okay for the most part because things are standardized. But to avoid some of those pitfalls, one thing most of these GUI programs let you do is do relative positioning. And that relative positioning is done using a layout manager. And so the layout manager there are different layout managers with different schemes on exactly how components will be laid out. So, you can have them just all come in a flow layout where they just come one after the other and stuff like that, grid layout, grid bag layout. You'll meet all these different kinds. So because you're laying out usually with a relative layout approach using a layout manager, the pack sort of figures out how everything should go together on that operating system in that window and sets the size of the window as well. That's what pack does. And once all of the window and all the components are set, then it makes the window itself visible. And so that's what's going on over there. And so then you can expand that to both not just put up a window, which won't do much, but also add other components like a label. So if you add a label, then you have to add it to the content panel of that frame. So this, as it says over here, you could also do a myFrame.getContentPane and then add it to that. But myFrame also gives you this shortcut where you can just add it directly. And what the add does is it takes that component, that label, remember it's kind of like a sticker, and sticks it onto the panel or the window pane, the invisible window pane of that window. And then so that thing becomes visible. Then you can do things like add a J button and a listener as well. So you can add a J button, you create the new J button, you can set its text, again using the dot operator, to whatever you want. Then you create a listener class, and the listener class can be created inside of your main application itself. This is an inner class. You can create anonymous classes, you can create external non-public classes, you can create external public classes. You have a variety of approaches. All of them are equivalent, and it depends on what the style is that's endorsed by the organization you're in or your own personal preference. In this case, it's an inner class that we've defined. and it has to implement some interface class. In this case, it implements the action listener interface class. This is like that catching a ball. So we're going to catch a ball. That's what we're saying. So we create our listener buddy, and this listener buddy catches balls. So we create the new buddy itself. We actually create our friend. If we don't have actual friends, we can create as many friends as we want in this virtual environment. And then we add an action listener to the player, the button that we have. And the action listener we add is my listener buddy, that new object that we just created. This is the process of registration. So this is where we register with the JVM, the Java Virtual Machine, that these two objects are going to play catch. You've got the button, which is the button player. Oops. There we go. And you've got the catcher, which is the listener buddy. And these two people will be throwing an event object to each other. What kind of event object? An action listener. That means they're going to throw a ball, not a frisbee, right? And then, of course, just like we did earlier with the label, you add the button player, and then we talked about the different layouts that they have. So you could, if you wanted to, I think you'd have to here. I'll comment this out. You do not need this one. If you did this, both the components would go on top of each other. So this is an intentional error. Remember we talked about the relative positions and the layout managers that these have. So by default, the frame has a border layout. So you tell it to utilize. Oh, we might have to, actually it doesn't have that by default. It has a flow layout by default. So what we want to do is we want to add the border layout. So we're going to also import the border layout library or the class definition. And then we can use a border layout to say, hey, you know what, the button should go up here in the north and the label can go in the middle. Then we invoke the pack method to sort of push it all together, set visible to be true, and then display the application, and then you can actually click on it and it'll do stuff. What will it do? Well, it depends what's implemented in that listener class. And in order to do something, it has to perform some action when that event is clicked. So that action that it performs is defined in a method called action performed. And the action performed receives as an argument from the JVM. You don't have to do anything about this. The JVM creates and packages the event and sends it as an argument to that action performed method. And so that event is encapsulated in this argument, which we call E. And we don't use it, so we don't care about what the event was. We don't care about details of whether it was a mouse click, what was it clicked, where was it clicked, all of that stuff. We don't care about that. We just say that, hey, when it's clicked, we're going to print out clicked. And that's it. That's what we're going to do. So we added that listener and we created the objects that we needed and we packed it all together. Here's the final version of it cleaned up without some of the errors that we had earlier in there. Some of those errors are intentional. So, if I was demoing it, with a little more time, I'd demo it for you and you could actually see it. But in this case, that's what we're essentially doing. We add the label, we add the button player. Still has an error. We need to add the import for the Java AWT. But in this case, what we're doing is rather than creating a whole inner class, instead we use an anonymous listener object. So in this case, we have a buddy, but we don't have an explicit buddy. We just say, hey, you know what? I add an action listener, and I'm going to create a new buddy. I don't know what their name is, but I'm going to have a new friend. I don't know who that friend is, but that friend will play catch. And when I throw the ball or the action element to them, they're going to print it all out. So there are other ways to do this as well, but you can use, like we did here, use an inner class. This is a class that's defined inside another class. Or you can use an anonymous listener object where we just create a new listener object that implements the action listener. Remember the action listener interface class that we have? The syntax is a little funky and confusing, but this is what the developers had. It'd be nice if they didn't have the functional notation with it, but they have it. It's not the most consistent, so we'll go with it. But you create a new action listener object. That's your anonymous buddy, and your anonymous buddy has the action perform method, same as in the inner class that we had over here. And it also performs the same action itself, which is just clicking. So we could, if we wanted to, add all of this stuff to the buttons that we create to, remember we said that the components have a certain component subclass called container, which is components that hold other components. One of those is a J panel. It's like that invisible window frame that we have, right? Or that invisible window pane that you have. So that can hold other objects, other components. And that's what we see. So we create a new invisible window pane, a J panel called My Panel, and we add the label and the button player to that panel. And then the rest of it is the same. This is still that anonymous object that we create. But in this case, what we add to the window frame itself is the panel that we created, that intermediate panel, not the individual components separately. We add the whole panel over here, pack it up, and set it to be visible. And so this is essentially what we're going to do. When you want to create a GUI component, to sum it up, a GUI class, what you'll do is you'll create the GUI component itself, like a JButton, and we'll create it the way you normally create objects from classes. You'll configure the GUI component. For example, you can set, if it's a button, you can set the text that it should display. Then you need to add the GUI component to the GUI container. If you're using an intermediate pane or a J panel, you'll add it to that. If you're adding it to the frame itself directly, you'll add it to the frame directly. And then you're going to connect listeners to the GUI component. So you're going to add an action listener if it's a button. If they're different, this is the one that that throws a ball. If there are other listeners or events you're interested in, like the frisbee, you'll add the appropriate listener method for that. In this case, you can create a new anonymous object, and that object will perform an action when that event is received. That action can be whatever you want. It doesn't have to be just a print line. It can be a whole bunch of other stuff. And then finally, you'll show it. You'll add the panel in this case because we added it to the intermediate panel. You'll add the panel to the frame itself. You could, if you want, add the button directly to the window frame itself. You'll set the default close operation for the frame, otherwise it won't go away when you end it, and then you'll show the frame. And that's it. That's your GUI application. All right, so I went on a little longer than I intended to, but I think you'll find that helpful, and we'll continue the discussion in the general questions forum as well. Best of luck, and I'll see you online. Bye-bye.